What is the difference between method overriding and method overloading in C#? Let's take a look at the definitions first, and then I'm going to show you some code examples that demonstrate the use of method overriding and method overloading in C#. What is method overriding? This is a feature which allows a subclass to provide a specific implementation of a method which is already defined in its superclass. When a method in the subclass has the same name, return type, and parameters as the method in the superclass, then this method in the subclass is set to override the method in the superclass. So, in order to have method overriding, you need to have two classes, a child and a parent class, and the parent class has already defined a method which the child class actually overrides to provide specific implementation. What is the method overloading then? The method overloading refers to the ability of a class to have more than one method with the same name, provided that the parameters are different in number, types, or both. Method overloading is a form of compile-time polymorphism where the method to be executed is determined by the compiler based on the method signature. Basically, when you have method overloading, this happens in the same class. We have two methods with the exact same name, and the way you can tell them apart is by the parameter types and numbers. Let's take a look at the first code example which demonstrates the methods overriding. I have two classes. My parent class is called gadget and my child class is called smartphone. And in my parent class, I have a single method which is turn on, and when executed, the method prints to the console, gadget is turning on, and we use the virtual keyword, which I'm going to discuss a little bit later. And for now, let's create two objects, my gadget, which is a gadget, and my phone, which is actually a smartphone. And we're going to execute the turn on method for each one of these objects. And since we are not overriding the method, it should print the gadget is turning on for each one of these objects. So let's run the program quickly. And I have gadget is turning on and gadget is turning on. Now let's use method overriding to override the behavior of the turn on method in the parent class. Okay, let me stop the program. Okay, and now in the child class, which is smartphone, which is the one that inherits from gadget, we are overriding the method using the same method name, which is turn on, and instead of gadget is turning on, we're printing the smartphone lights up and shows home screen. So right now, when I run the program, I should see the gadget is turning on printed for the my gadget method turn on, and then smartphone lights up and shows home screen for the smartphone method turn on. So let's run the program quickly. Okay, I have gadget is turning on and smartphone lights up and shows home screen. And if I create another class, let's call it maybe radio. Okay, radio, which inherits from gadget as well, and I can override the method to, I don't know, let's go play music, and we can create another object here, which is my radio equals new radio, and if we print the, if we run the turn on method, we should see play music. So let's run the program, and I have now gadget is turning on, smartphone lights up and shows home screen, and playing music for the last object, which is my radio. So this is basically method overriding. We have a method in the parent class, which is then overridden in the child class. Now let's discuss the importance of the virtual keyword quickly. In C#, the virtual keyword is actually used to modify a method property, indexer, or event declaration, and actually it shows that the entity can be overridden in a derived class. So this is why we use the virtual keyword when declaring the turn on method, to indicate that this method can be overridden. Okay, and one last thing about method overriding, which is actually quite important. Can you override any method? Well, in C# you cannot override any method So let's quickly discuss which methods you can override and which ones you cannot. You can now pause the screen and read the text which describes which methods you can actually override in C# and which ones you cannot. But to sum it up, make a method overrideable, you need to declare it with the virtual keywords, and when you actually override the method in the child class, you need to use the override keyword. And when it comes to non-virtual methods, they cannot be overridden, meaning if a method in the base class is not actually marked as virtual, abstract, or part of an interface, it cannot be overridden. And the static methods actually belong to the class and not to any instance of the class, and they cannot be overridden. Again, when it comes to constructors and finalizers, they cannot be overridden. And when it comes to the seal methods, if the method in the base class is marked with the seal keyword, it actually also cannot be overridden. And a little bit maybe unrelated, but when it comes to the abstract methods, in abstract classes, the abstract methods actually must be overridden by the derived classes, by the child classes. So let's take a look at two more code examples quickly, which will show that we cannot override the non-virtual methods and we can actually not override the seal methods as well. Okay, now let's modify the first code example to show that we cannot override a sealed method. We are still going to keep the gadget class and the smartphone class. We're going to create a new class which actually inherits from smartphone. We can call it new wave smartphone for some reason, and we inherit from smartphone, and we are going to override the turn on method. We're going to print the new wave smartphone lights up. It shows something else. Why not? And now, so far everything works just fine. Now, if I mark this method here as sealed, I'm going to get an error which is actually states the turn on method cannot override inherited member because it is sealed. So a method which is marked with the seal keyword cannot be overridden. And now let's again change the code example to demonstrate that you need to use the virtual keyword if you want to make this method overridable. You can see that if I leave the virtual keyword here, I'm able to override the turn on method. If I remove the virtual keyword, I'm going to get an error, and the error says cannot override the inherited member because it is not marked virtual, abstract, or override. Now let's create a code example which demonstrates the method overloading. I'm going to create a class which is called calculator, and we are going to have several methods inside our class which actually have the same name, and this describes method overloading. So let's start. I'm going to have a public add class which takes two input parameters, and it's going to be int a and b, and we're going to return a plus b, and then we're going to have the same method, but this time we're going to have three parameters, int c, and we can actually keep going. We can have the same method which takes two doubles, and we can also return a double. And as you can see, we can have several methods with the exact same name, and this is what method overloading actually is. As long as you have different input parameters or different number of input parameters, you can have the method overloaded in the same class. If you remember from the method overloading definition, the return type actually does not allow you to overload a method. So let's try that. We're going to have the same method, and let's make it return type string, and I'm going to have a int result equals a plus b and return result to string. Okay, you see that we cannot overload the method simply by changing the return type, and the error that we're getting is the type program calculator already defines a member code add with the same parameter types. So in order to overload a method, you need to have either different type of parameters or different number of parameters. So right here, as I did before, if I have different parameter types, even though they're the same number, I can overload the method. And right here, if I create a calculator object, I can actually execute these methods. And let's do that quickly. Let's make it a result int equals calculator, add these two numbers, and then double result double, and let's print this to the console. Okay, int result is our result int, and double result is our result double. So let's run the program, and we have the int result is 3 and double result is 5. And the same as overriding, can you overload any method in C#? Well, in C# you can actually overload most methods, but here the rules that you need to keep in mind when doing that: each version must have a unique signature, the return types do not count, the access modifiers do not matter, and you cannot overload a method such as the one version is static and another one is an instance method. And when it comes to constructors and destructors, the constructors can be overloaded, the destructors cannot be overloaded. And even though when we are discussing method overloading, we're discussing the same class, you can actually overload a method in two different classes, which are child and parent class, but there are some nuances that I'm going to discuss quickly with a simple code example. So let's do that next. And now in the last code example of this video, let's quickly discuss the method overloading when you have two classes, parent and child class. I have my calculator class, which is the parent class, and I have the smartphone calculator child class, which inherits from calculator. And I have two methods, add, in the parent and the child class, which actually have the same name, add, and they have different number of parameters. The parent add method has two parameters, int a and int b, and in the smartphone calculator we have the add method with three parameters, int a, int b, and int c. Why is this actually overloading and not overriding? Well, it is not overriding because we do not have the virtual keyword here in front of our method, and we do not have the override keyword in the child class method. So this is not overriding, this is actually overloading, and these two methods are treated as separate methods. And inside my main method, if I create two objects, the calculator and the smartphone calculator, in the calculator class, I can use only this method here, the add with the two parameters, 2 and 5. And in the smartphone calculator, I can use the parents class method, the add with the two parameters, and the smartphone calculator class method add with the three parameters. If I change this object from smartphone calculator to calculator, I cannot use the overloaded method. I can only use the parent method, which takes two parameters, int a and int b. So there are nuances when it comes to overloading the methods in two different classes, which are parent and child class. And that was all for today. Thank you for watching.